Good afternoon, everyone. Stefan Wick here, QA Manager on the Windows Developer Platform team. Before I get started, I actually have an announcement to make here. I just got that note. It's about the grand prize drawing for the Windows Code Challenge. So the time for that drawing has been changed from 6 p.m. to 6:30. So if you participated in that event, please have your raffle ticket ready and come to the second floor in front of the DJ booth at 6:30. So please take a note of that. Also, second announcement, I have a nice Nokia headphone here to give away to the audience. So at the end of the session, I will ask a trivia question about something that I talked about in this presentation. So first person who knows the answer will receive the headphones. Okay, so let's get started. Today, I want to share with you a number of critical tips and best practices for building successful applications with the new universal XAML platform for Windows and Windows Phone 8.1. A little bit more about myself and my role at Microsoft. So over the last year, my team was chartered with testing this new platform. And as part of this job, we were not only actively finding all the bugs in APIs and controls. We also worked very closely with a number of teams that built the first set of apps on this new universal platform. So some of the internal applications that we're bringing out now or pretty soon, we've worked very closely with. And as part of that process, we've identified a number of best practices, number of tips and tricks, and also a number of common pitfalls and things to avoid in order to build a really successful, high-quality, high-performance app. And today I want to share some of this with you in this presentation. So, as I said, the talk is about the universal XAML platform. I will not cover any topics about HTML or about the Windows Phone Silverlight platform. I will use Windows Phone Silverlight platform a little bit as a reference point when I talk about some of the improvements in platform and tooling, but everything I talk about is really about the new universal XAML 8.1 platform. So the focus of the talk is really about building high-quality apps and making them successful by applying the best practices and also by testing for the right things in your development process. Performance is a big part of quality. Performance is what makes your app stand out from the competition. Also, performance will help you to reach the lowest end devices. We'll talk a little bit more about reach as well in the context of making your app successful on more form factors and in more markets. So let's start with performance. Performance is an important differentiator. We see a noticeable correlation between apps that have good performance characteristics and their review ratings. So it's something you really want to pay attention to. As we converge the new platform to work on the phone devices, we put a lot of effort into the engineering to make the platform performant by default so that all apps can take advantage of it directly without having to do a lot of work. So that was of critical importance to us because we want to bring all the new 8.1 capabilities to all the devices today, all the phones that run the 8.0 operating system today. So they will receive that as an update, so we want to make sure everything runs great there. So you see on the left side, some of the high-level improvements that we put a lot of energy on. But on the other hand, there's also a responsibility for you guys as the app developers to really kind of follow those best practices and test for performance to make sure your apps actually work across the entire spectrum of devices. And there's a number of tools that we are including in the latest toolset, in the latest SDK that we are releasing that make this a lot easier for you. Some of these tools you may already be familiar with if you have developed Windows Store applications with Visual Studio 2013. But now we're making a lot of these also available for phone development. So there is, a big improvement on the tooling side compared to the Windows Phone 8.0 story. So let's jump right into a couple of demos here to showcase what I'm talking about. So first rule of performance testing always is, test on a real device. You don't want to test for performance in an emulator because that doesn't give you all the right characteristics. But on the device, and preferably on a lower end device, gives you a better experience. So see, that works. Okay, so this is my Windows Phone here running 8.1. And so what I've done is I've created an application first using the Windows Phone Silverlight SDK for 8.0. And then I went ahead and created the exact same application using the new Universal XAML platform. And so this will showcase some of the improvements that we've made into the platform, where pretty much I'm running the exact same application code, I'm solving the exact same problem, but I'm getting much improved performance results. So let me start the 8.0 version here. And it's a very simple application. All it does, it sends a keyword to a Flickr web service, which then returns all the recent photos that have been tagged with this keyword. And so I'm choosing a keyword here that hopefully is safe for a professional environment like this, because this is all live content, so it could be anything. And so what I'm doing here is measure the working set of my application. So I started out with an empty application around 9 megabytes, and I'm ending up at around 43 after downloading all these images. They're pretty, sizable images. They're not exactly small. So I want to do the same now with my 8.1 universal app here that I'm running on my phone. The baseline is roughly the same, 8 point something megabyte. And so I should be getting pretty much the same images here, same size, same number of images. And so I'm ending up here at around 13 or almost 14 megabyte. So let me do my task switcher here. So I don't know if you can still read that and compare the numbers. So in my 8.0 version, and compared to the 8.1 version, there's about 30 megabyte difference in this scenario. So that's a lot of megabytes that we're giving back to you as the app developer, so you can do more creative stuff, even on low memory devices and the lowest end phones, that you can put additional content and make your customers happy. So that's a huge improvement, and gets even better because since it's now a common universal platform that we are delivering, all the work, all the optimization that we've done to make things great on low-end phones also goes back to your PC and to your tablet, and you take advantage of the same improvements. So in fact, this optimization that I've just shown here around images, this is actually included in the update for Windows 8.1 that we announced yesterday. So if you have a Windows Store app today that uses a couple of images, go measure your working set today. Now measure it again after you receive the update, and you will see a noticeable better working set for your application. In fact, we've done those measurements for many of the popular apps in the store, and we found a lot of these apps have a reduced working set by 50% and even more in some cases. So that's a huge win for the platform overall, and so that's something that you get for free just by using the platform in the default way. However, there are some aspects where you want to make sure you actually do the right thing, and that's what I want to focus on. One key feature, obviously, in scenarios like this is virtualization, right? When we put in all these images into a list, virtualization is a key factor here. And I want to drill into virtualization a little bit, because we've seen with many of the app teams that we've worked with that even though virtualization is baked into the platform, it's there by default in all the controls now that you expect virtualization to be in. Since XAML is a very flexible platform, oftentimes app development teams find a way to kind of drop out of virtualization and drop out of the fast path. And so I want to show you how you can test for that and how you can prevent that from happening to you. So what I want to show you now is an application that I will be using throughout the presentation. It's a universal XAML app. You may have seen it in some of the other presentations as well. And so here's the desktop version of it as well. So it's one code base that I'm running on both platforms here. And in this application, I have a players list that is potentially pretty large. In my case, it's 100 players, but it could be much larger. And I want to make sure it's actually virtualized before I release my app. So I'm about to put my app in the store, but I want to do all the right testing before I do that to make sure it can really scale up to my users' need and can work well on all devices. So how do I actually verify that this list is virtualized and stays virtualized? So let me look at the XAML here a little bit. Here's my players list. And so here's the XAML for my pivot. And I have my list view over here. So one thing you notice, I'm using a custom list view here for testing purposes. So there's nothing scary here. Let's just look at this one. It's really just derived from the list view control. And all I'm doing here is override two methods. The first one, prepare a container for item override. This one gets called by the runtime whenever an item is about to be prepared and realized to come into the list. And then the second one is called by the runtime whenever we have determined an item is no longer used for the time being and we can get rid of it for now. So basically by sitting in these two methods and monitoring what's happening, I can literally see virtualization in action and verify that things work as I expect. So let me run this in the debugger. Oops, let me do this again. Okay. So launching this in the debugger. Now I go to my players list. And now in the debug output, what you see is I'm preparing all the items to item number 18. So this looks pretty good. I currently have 6 items on the screen, and so our rule of thumb is 2 extra screen sizes is what we're kind of preparing, so that that will allow a really good scrolling performance. And so now if you keep watching the output here, you see that as I scroll through, more items get prepared from the bottom, and the items on the top get released. So here I can see, hey, virtualization is working. It does the right thing for me. I'm pretty confident that I can ship this app and this page will scale to large numbers. So that's all great, and it's kind of what you expect. But now, why is it important to actually check for this? Because there are many ways you can actually make mistakes in your code that will then drop you out of this good path. So let me see how that could happen. Let's say, for example, tomorrow your designer decides, hey, we need to change the UI a little bit. We need to have a header on top of this list. So no problem. Let's just write this real quick. We'll put a header on top of our list by just writing a little bit of XAML. So I put a text block here and give it some color. And that should be all we need, right? Stack panel, here's my header. And now when we run it again, pay close attention. Now I go to my players list. The header is there, seems to be working, but there are 2 things. I don't know if you notice it. First of all, the page transition was much, much slower than it was before. It took about maybe a second. And then secondly, we're seeing, oh, we're preparing all 100 items immediately. So that's a problem. So somehow we dropped out of virtualization here. So if you only do casual testing, you might not notice it with a data set of 100 players. It may still look okay to you, and you ship your app. And then the next customer who actually has 5,000 players in their list, they will see a terrible performance. They will see the page transition will take 5 seconds or longer, and the memory will go through the roof or even run out of memory because nothing is virtualized. So what happened, and how do we fix it? So by putting a stack panel around this, using the stack panel layout, we're actually getting an infinite layout. Stack panel by design provides infinite room to its children. So putting the text block there, works, but now the list view has infinite room to grow. So it doesn't know where to stop. So then it doesn't know how to virtualize because it thinks, it can just, realize all items and put them into the stack panel. So obviously, a small mistake in the XAML can now drop us out of virtualization, and we have a big problem. So let's fix it real quick. Better way would be to use a grid here and define 2 rows for this grid. 1 row for my text block with height for auto, so it gets sized correctly just for what the text block needs. So I'll put this in grid row 0, and then the second row for the remainder of the available space for my list view. So I put this in grid row 1, and now when I launch this again, my performance should be back to good. Oops, wrong button. Performance is good. And you see virtualization works again. I only actually realize the items that I need, and I get rid of those that I don't need. So one thing to add to your checklist, actually verify your long lists are virtualized. So now there are a number of other performance problems that your app can show or can have, and it's not always easy to predict what those might be and write proactive test cases for it. So one good and easy way to actually stay on top of these sort of unexpected performance problems is to just monitor your performance characteristics while you do your functional testing, right? So this shouldn't be, any extra work for you. Just by doing your normal testing, attach, a performance monitor and monitor what's happening. So with the new tools for the Windows Phone 8.1, we now include a performance monitor that makes this really easy for you. And I will show this in action here with my Golf app here again. So first of all, I can connect this monitor to either my device or to any of my emulators. And so I'm violating my own rule here. Now I'm doing performance testing on the emulator, but that's mostly for demo convenience. So I will connect to my emulator, and now I can start performance monitoring. And what I want to do is just monitor my applications. I don't want to monitor anything else on the phone. So this looks good. There's no CPU, 22 megabytes of baseline working set. And so now I can go through my scenarios here and test my application, perform my functional testing, and just while I'm doing it, I'm capturing performance data that I can then view or also even put into the Windows Performance Analyzer for a real deep analysis. So what I'm seeing here, looks pretty okay. The memory goes up as I navigate deeper into my application, but then it comes back down again, when I navigate back. So no real concern here. So now let me do some extra steps in my testing. So I'm navigating to some other content here in my pages. As I test out my functionality. And so now what I'm seeing is a little bit of a different pattern. if I look at my memory indicator in the performance monitor, what do you think I'm seeing here? Yeah, exactly. There's a leak or an object lifetime problem of some sort. So just by monitoring this on the side, I have discovered something that requires a follow-up where I need to do some more digging and some more debugging. So it didn't really require much extra work or coding on my part, but I have found something that in my casual testing I probably would not have. So I'll take a note of that. I'll leave the bug in for now because I'll come back to it a little bit later in another demo. So similar to finding memory problems, you can use the monitor to find CPU problems. So here I have a properly coded animation that's using very little CPU time because it mostly runs on the GPU. So I'm in the low single digits of my CPU. But now on another page, I have another animation that actually is much higher in double digits and gets worse as I keep navigating to this content. So again, this is something you wouldn't see in your casual testing. The animation still looks good. There's no problem. The only thing you might notice is that the device gets really hot because you're using so much CPU. But these are terrible bugs that you don't want to ship with. You don't want to burn your customer's battery, and also you don't want to waste their memory. So these are things you want to catch and follow up and fix. And this is an easy way to just kind of catch and find them. Going back to my deck for a minute. So taking a step back, why do we want to do all this work for performance, and why do we care so much? Obviously, we care about the user experience a lot. We want to ship best possible and fastest possible applications, but also we want to ensure that our application has the best possible reach to all the wide variety of low-end devices. This is especially important for memory because if your app goes above the memory cap that we're setting on those devices, then your app simply will not run on those devices. So that's important to keep in mind, important to monitor your working set. There are other important aspects of reach that I want to point out. One is optimizing for different screen sizes, different screen resolutions, different themes, and the like. So that is another thing where the 8.1 XAML platform makes things really easy for you, and the tooling supports it very well. But still, there's so much flexibility in the platform that it's also quite easy and quite possible for an app developer to create some bugs that prevent your app from looking awesome on some of these configurations. So there was a talk by Peter Tor yesterday. So that's highly recommended to watch on that topic, how to really optimize your app for all these different sizes. So go watch that recording. And also want to point out, the Universal project that we now support in Visual Studio. That's a great way for you to maximize your reach. If you have a Windows app today in the store, add a phone project to it and just bring it to the phone, or vice versa. If you start with a phone project, add a Windows flavor for it and then bring it to the Windows Store as well. So that's the big multiplier there. And last but not least, I want to call out international. Huge multiplier there. That's where a lot of devices are being sold. And even if you don't want to necessarily localize your app, meaning translating all the UI and localizing all the content, just by testing for it and making sure the app actually works on these markets, you can gain a lot of reach very easily. But then also do consider localizing to those markets because the tools really make it easy and it can have a huge effect on your reach and your overall downloads. So I want to touch on that a little bit, globalization and localization, using, again, my little golf application. There is a dedicated talk about that tomorrow morning at 9 a.m. For those who wake up early. So that should be a great talk that goes into all the details here. But I want to at least touch on it quickly, and because I want to finish my golf application. It's almost ready to be submitted to the store, but I want to ship it to a worldwide audience. So I want to do some last-minute testing here and make sure it can really go there. So what I want to do now is I want to run it in a different emulator. So we have now for Windows Phone 8.1, we have included 6 different emulators here. For all the different screen sizes, resolutions, aspect ratios, and all that. And so you can configure them separately for language, for themes, and some of the other configuration aspects. So what I've done here is I've configured one emulator to be my German test environment, and I also set it to the light theme. And I'm using an aspect ratio and screen resolution that's different from my regular test environment and different from my actual device that I'm using for testing. So it gives me some additional confidence, just by doing the same testing on a different configuration. So let me now deploy my app to this emulator and see what happens. So it crashes right away, so that's not good. It was working fine, obviously, on my English device and on my English emulator, but it looks like in the German environment it doesn't even start. So that's a problem. So let me see what happened here. So I have some functionality here that on startup figures out what is the nearest golf course for my current location. So I check what's the location, and then I compare to a list of golf courses to find out what's the closest one. And now I'm getting an exception saying, okay, latitude must be between -90 and +90. That seems reasonable, but how did it go wrong? So let me check the string value that I'm passing in. Not sure if you can read it there. I'm passing in a string value of 37.78, so that seems okay. But then when I look at the converted value after converting this to double, I see that I'm actually getting 33,778 as a double value. So that's obviously not a valid latitude. And the reason for this problem is because in different locales use different formats for dates, for times, for numbers, currencies, and so on and so forth. And if your code is not aware of these differences, it may just fail miserably on those markets, on those machines. So, and this is exactly what happened here. So this seems like potentially a kind of a daunting problem. Now I have to go review all my code for possible problems like that. So this could be a lot of work. But the good news is that the code analysis in Visual Studio can actually do that for you. So if I kick that off here, what's happening here? I'm doing a static code analysis of all my application code for certain rules, including globalization rules, and so it actually identifies these 2 lines of code here, and it tells me exactly what I just explained, basically what my bug is and how to fix it. So it tells me to use the invariant culture to address the problem, and so I'll go ahead and do that. So now I should be good. Let me try to launch it again. And my emulator comes up and doesn't crash anymore. So that's awesome. So of course it's still an English application. I haven't changed the UI or anything, but at least it's working. So that's progress. Now, if you watch closely, I actually can see another problem here. It looks like the designer kind of hard-coded the UI with the dark theme in mind. So if you watch the status bar on top here, you see kind of a UI glitch here. So that's another kind of bug that you can easily catch by doing some of your testing in the light theme. And actually even worse, if I now go to my players list, what I see here is I have now white text on white background because my designer hard-coded those values in the XAML. So another bad bug that you could easily miss if you don't know what to test for and how to test for these things. But this is again something you'd want to catch before you submit to the store, because otherwise this will probably give you a 1-star rating or less. So a couple of good bugs found here, but at least my app runs now. Now what I want to do as a next step before I move on to the next topic, I actually want to go ahead and localize my content, because it's really easy now with the tooling that we provide. So in my application, I've already tagged all my string resources correctly. So now all I need to do is really just ask the Bing translation service to translate these strings for me. So I'll do that here on the fly. So it takes all the English strings, sends it up to the service, and I get the German translation back here. And so now when I hit F5 again and run it in my German emulator, it now pulls the German strings from the resource dictionary. And so I'm done. Everything's localized. I'm ready to ship not only to the English-speaking markets, also to German and other markets as well. So now I'm getting really close to shipping my app, starting to feel very good about it. Going back to the slides. One last related topic here on localization. The tools also support pseudo-localization, which is kind of a nice, quick way to test as well. You might want to add this to your portfolio if you do localize. By doing pseudo-localization up front, you can identify a lot of problems. For example, if you have hard-coded strings in your app that aren't set up for localization, you would find them here because they would show up as non-pseudo-localized. Also, you can find layout problems that may occur once your string length changes due to translation. And last but not least, you can find problems like over-localization. For example, if you localize something that's really a brand name or a trademark or something like that should not be localized. So a nice little trick also helps find some good bugs. So now we found a number of interesting bugs already in my application, and I want to use this really to kind of highlight the importance of testing and quality in the development process of your applications. We've seen that these bugs that we found are actually really bad bugs, right? They are not just small fit and finish or glitches. They are things that users will find terrible, and they will probably go uninstall your app and go with the competition. But then again, they might be hard to catch if you don't know really how to test for them. So really, testing is what makes a good app idea into a really great and successful application. So the two key things to remember here are really monitor your perf metrics throughout your development process, and also be aware of all the different configurations and states that your app can be used in the real world. So that's really important too. And so there are a couple that we already touched on, making sure it looks really good on all screens. Also, we didn't talk about network, but that's another key one. In mobile applications, your network connections are changing all the time. They can be good, they can be non-existent, they can be bad. You want to make sure your app is robust against all these changes. Is your app theme aware? We've seen a couple of problems in my little app here. Does it require optional hardware? What if you require front-facing camera and someone decides to run it on a device that doesn't have one? So I want to make sure you kind of degrade gracefully there as well. And last but not least, is your app world ready, or does it just crash on other markets? So those are important things, and the full list is probably a little bit longer than this, but those are good things to be aware of. Now, this may seem a little bit overwhelming. Hey, there's so many configurations. How can I do all my testing? So good thing that comes here handy is use test automation. And with the new tools that we have now available in Visual Studio 2013, automation for universal XAML applications is much easier, and it's the first time we really have this available for phone applications as well. So in the past we had some unit test support, which was kind of basic, but now we also have coded UI testing support across both Windows and Windows Phone, and I will show that in just a second. So yeah, with your investments in automation, you can test more configurations in less time. You can test more frequently. You can catch regressions earlier, and so on and so forth. Also, these investments in functional testing, you can also reuse those for some of your stress testing, performance testing, and leak testing. Sometimes it's as easy as just running your functional tests in a big loop over and over again, and it will find you a whole ton of new bugs around stability or memory usage. I also want to call out that manual testing, I think, is still an important aspect of your test plan. So you do want to make sure you spend some quality time with your application before you put it in the store, because that's really the only way to get the full validation of the user experience. So now I want to go into test automation and show that in some practical examples here. So switching back to this screen. So I'm done with this one, and so I'll use the English emulator here again. And so using my same application, I want to now write some tests for it in an automated way. And so I've done a simple one here. I want to walk you through this real quick. Well, before I do that, actually, I want to make sure I'll show you how to get started, since the project was already created. So one of the new project templates now that you see here for both Windows Phone as well as Windows apps is where is it? Coded UI test project. So this is the type of project that I'm working on here. And so this allows you to write an automated UI test in a very easy way, and you can write code to customize and extend it. So here's my first test that I want to look at. And so just to walk you through the anatomy here a little bit. So in the first line, what it does is just, it launches my application, and then the next two lines, basically what I'm doing is I'm hitting this hyperlink, and I'm waiting for the pivot to show up. And then next three lines, I'm swiping over, and I'm tapping on this guy. And then here I have my validation logic. I verify that the right image is shown for this guy to make sure the right things happen. And then I have some other code here to swipe over, and then ultimately to go back to complete my test and exit the application. So this is the whole test, and let's see it in action real quick. So I can run it here from my Test Explorer, And so I can run this either in the emulator or on my device where the same app is installed. So it works on both. So it's already done. It went through this whole scenario, and here it passed. So this way, you can build up very easily, a nice suite of tests for your application, and cover all your content, all your pages, all your functionality in a very easy way, and you can just write it in code. So that's all very convenient. But I want to show how maybe you can actually take this a little bit further. So let me copy this and create a second test here. And I'll just remove this so I won't run this again. So in my second test, what I want to do is I'll just put this in a loop here for a couple of iterations. And now that's pretty much all I need. So I have this loop going on, and so I'll just run this in a loop. And my goal or my purpose here is I will use this, as kind of a stress test, but also maybe to monitor my performance. So I could run this, for an hour or however long, and see how I behave. And so while it's running, I'll also attach my performance monitor here. Oh, first I need to connect, and then I can start. And now I'm monitoring the application again. And so if you look at the steps, so those were actually the same steps that previously we found that actually repro our leak. So now what I can do is, since I have it automated, I can just attach my my monitor to my automation, and I can see some of these problems that are happening during the execution. So I see here my steep climb of the memory, so I know there was a problem. What I can do also is I can actually use the performance recorder here, while I'm running my automation. And what this does, it captures all the ETW events from the platform and from the application, and it gives me a trace file, an ETL file, that I can then load up in the Windows Performance Analyzer and do a really, really deep analysis of what's really happening in the application and in the platform, and see where the problems are. And there's a dedicated talk on Windows Performance Analyzer as well. I'll have that in my reference. We won't have time to go deep there, but pointing this out, those are all things you can do here with the new Windows Phone Power Tools. So we've seen, there is a problem when I do these particular steps in my application in terms of memory. So since I've already nailed down these steps, why don't I just go debug this using the new diagnostics tools that are available now in Visual Studio 2013. Not only for Windows Store apps, but now also for Windows Phone 8.1 apps. So going back to my application here, I want to make sure I run in the right emulator. So I have performance diagnostics tools here, and so those are pretty much the same that you know from debugging Windows Store apps. So I have a couple of different tools available here for CPU usage, energy consumption, memory usage, as well as UI responsiveness. So the particular problem I want to debug here is the memory usage. So I'll go ahead and select this one. And so starting this, we'll launch it in the emulator or the device, whatever I choose. And so now I'm going to go ahead and do my scenario, which was this one. And now I'm going to take a snapshot here. And what I want to do is now repeat this a few times to really collect a lot of evidence for the problem, a lot of data. And one more time. So take another snapshot here and hit stop. So now I have created a baseline. I have, reproduced the problem a couple of times, and so here's what the diagnostics tools tell me. So we're doing a diff between the snapshot and the baseline, and pretty clearly, I'm seeing there's a problem. The snapshot has 22 additional megabytes and almost 700 additional objects. So this will be good data to drill in. And so what I see here, it's very obvious. I have this player details page that obviously, it should disappear when I navigate back from it, but for some reason it stays in memory, and that page, seems pretty large because it has, a number of images and who knows what. So that's 32 megabytes here. So each instant is like 8 megabytes, and so that's where the big delta comes from. So now I can select these instances here that really shouldn't be there, and I can take a look here. What are the paths to root? And what I'm seeing here is there is an event handler for the back pressed event that's holding on to these pages. So this is good information for me to go into the code here. So here's the player details. I actually want to look at the C# file here, and yeah, it's right here. So so we have a back press event here, and what's happening here is when my pivot changes to to a particular item, in this case it's the third item. I want to do some custom back button handling here, which is a valid thing to do. So I attach an event handler, but this is a global event handler that I'm attaching, and I'm not cleaning that one up after I'm done with my page. So what this does is effectively it gives my page the lifetime of the application, so it never cleans up. And so since the page stays around, all the elements, the entire tree of that page and the resources associated with that also still get referenced because it's a tree-based system, and none of those images get released. That's why the leak is so large and significant. So the fix is very easy. I just need to unsubscribe from that event when I'm done with the page, and then the leak goes away. So. But yeah, these types of leaks or object lifetime issues, they happen all the time, and so it's good to have an eye out for that, and it's good to have the tools available to detect these. So we're almost done. I wanted to, go back here to the deck and point out a couple of related talks. So there is Dan Taylor's talk about the diagnostics tools in Visual Studio. I think that talk was yesterday, but that would be a good recording to watch. It goes into great details on some of the memory and CPU and other diagnostics tools in Visual Studio. Then Lalitra Fernando's talk, that is, I believe, tomorrow, has some great details on the Windows Performance Analyzer and how to analyze the traces that you can take out of the Windows Phone power tools and then put into the Windows Performance Analyzer. Prachi Bora tomorrow will talk about automated testing for XAML apps, so going into much more details on coded UI testing. Then Peter Thor had the talk about optimizing for different screen sizes, so that should be a good one to watch the recording for. Also tomorrow morning, I mentioned there is the Apps Without Borders talk from Cameron. So he will talk a lot about localization and globalization. And then last but not least, Tim, Sean's, and Rohan's talk about general, universal XAML app development, XAML UI framework and controls. Those are also two great talks to watch in this context. Before we close, I have the question for you. So my trivia question is, how many Windows Phone 8.1 emulators are available? Very good. And I'll do that in a minute. So thanks for that. And yeah, thank you very much for attending. Really appreciate your time for coming to my talk. And also, please remember to submit your evaluation online. That will help us plan for the next events. Thank you very much. And I'll be available for a couple more questions here if you want.